back to your book, back to Building Agentic AI. Let's fast forward a little bit to kind of another exciting moment in your book, which is chapter 7, where you present some counterintuitive findings, the kinds of counterintuitive findings you would present with a lot of excitement at an in-person lecture. And so you do benchmarking with reasoning models. So using the Math QA dataset, Humanities Last Exam, and you found no obvious correlation between the level of reasoning and the LLM's performance. That is surprising. What do you make of that? Like, tell us a bit more detail about this experiment and the surprising results.
Yeah, and it's actually a pretty consistent result. I know that if you look up benchmarks, that's the first thing someone's going to say when they hear this is like, well, no, if you look at the benchmarks from Anthropic, clearly the reasoning is going to lead to better results. Yeah, there are a lot more benchmarks out there that Anthropic has time to inform you of. And if you run them on the other benchmarks they're not reporting, you are going to see the opposite. In fact, not in a later chapter, I also do other benchmarks with reasoning, and even if they do show a correlation, it's maybe 1 or 2% increase in accuracy and a 2x increase in cost. So on one side of the coin, the AI does not get better at the task when you add more reasoning. On the other side of the coin, even when it does, it almost never, in my consulting, outweighs the cost of having that reasoning turned on, and you are better spent that time prompting, few shot engineering, building your own kind of reasoning traces that are smaller, shorter, and more succinct in what you are trying to do. So it's strange. And again, like I said, it's not always the case that reasoning doesn't yield better results, but it's really important to know that it is not a 100% correlation that when you turn on and increase reasoning, performance at a task will get better. That is not a guarantee. That's all I want to say. It's not that it's not a guarantee, or rather it's not that it's not going to happen, is that it's not a guarantee.
Yeah. And so the key thing here that in case I didn't make this explicit when I brought up this topic of reasoning models, what I mean is, so the first kind of really well-known reasoning model was O1 from OpenAI. And
I would argue it's R1 from DeepSeek was the first reasoning model.
I guess but that people would probably have used. I mean, maybe amongst our listeners, R1 might be something that people use all the time, but in the general public.
But you're right. Oh yeah, O1.
And so those reasoning models, they spend time before just spitting out an output. So when in your typical ChatGPT setup or Claude setup without reasoning, you have this stream of consciousness spit out immediately. The reasoning models were the first time that you weren't getting that, where behind the scenes, this processing is happening where it is still just generating output, but it's reviewing that output. It's using it to come up with summary points and to consider different options. And so you can wait huge amounts of time, depending on how you set up the reasoning model to work. You can wait huge amounts of time before anything is output to you as a user on the screen. And so in your book, you mention that your reasoning benchmark evaluation took 5 hours for just 180 LLM calls.
Yeah.
And that
and a lot of money, to be clear. It's very expensive.
It can cost a lot of money for sure. And in contrast, 180 LLM calls, if we were doing immediate output results, not using a reasoning model, you could have done 180 LLM calls in seconds or minutes.
Oh, absolutely. Yes. And to be clear, the reasoning outputs, to your point, it's the same stream of consciousness. It's just you don't get to see it. OpenAI and Anthropic and Gemini, when they make these reasoning models, they train the models to perform this reasoning, but it's all just autoregressive next token prediction. It's just that they've done it in a format in which the UI can basically hide it from you until the model basically raises its hand and says, okay, I'm ready now. I can actually talk to the user. I'm done thinking. So you can induce a level of reasoning like that simply by saying, think through the problem before answering the question. The way that it gets better over time is how you train the AI to produce those reasoning steps, meaning what methods are being used to teach the LLM to produce that reasoning. One of the funnier things you can do with a reasoning model is literally just say hi to it And I almost put this case study in the book where for every reasoning model, at every reasoning effort, like how much reasoning, all I wanted to do was just say hello and see how much reasoning it produced just to say hi back to me. And because sometimes it would produce a whole paragraph. There was one model, who I won't say out loud, who produced 3 paragraphs of reasoning very genuinely along the lines of, the user is saying a question, but I've been trained to do this. Maybe they're trying to ask me a task under the question. Maybe they're trying to do this. For now, I'll just say hello and see what they want. And then it says, hello, how can I help you today? I was like, oh, I waited 30 seconds for you to say hello to me.